Today I'm going to be doing something with my Arduino that you should not do because I'm going to be trying to use high voltages through the I/O pins and actually measure their durability and really test their electrical characteristics. But I have a theory that I may be able to get away with it using that resistor. So what I'll be doing is stepping the voltage, starting at 5 volts and stepping it up. I'll be applying a supply signal to that leg. That's pin 12, and then pin 13, which of course is the LED on the Arduino, will be constantly reading the state of pin 12. And if pin 12 ever breaks because it got zapped with 24 volts or something, then pin 13 will either be stuck on or stuck off because pin 12 will be destroyed. And that will be the purpose of this test. And if it works or if it doesn't break, then that will be kind of interesting result because, I mean, who would expect that you'd be able to use a higher voltage than 5 volts with the Arduino and not break it? I'm here in the electronics shop, and today we're going to be doing something to an Arduino that I've wanted to do for a little while, but that I would not recommend that you do at home. I'm testing the durability of the I/O pins. Why? Well, I mean, I have a project and I have 24 volts and I want to use my Arduino with it, which is dumb, but I'm going to try. So here's the concept. Arduino runs on 5 volts and its I/O pins are rated for 5 volts, right? And actually the data sheet, what it says is the injection current, which is the current going into the I/O pin, cannot exceed 1 milliamp, and if it does, it's fried. So if you have 5 volts going straight in, like, you should have a current limiting resistor, but if you put 5 volts straight on it, I think it's fine, it's protected. But if you had more than 5 volts, theoretically, what if you had a current limiting resistor? This is a 47K resistor, just to make sure that that current would not exceed what the data sheet said was the absolute rating. Would the pin still survive? So that is what we are testing today. I have my DC supply set to 5 volts for starters, and what it should do is turn on LED 13, or the LED on pin 13, anytime pin 12 is read as a high. So pin 12 is the pin that we're going to be testing the durability of. Pin 13 is not, it's just the LED that's responding to or mimicking the state of pin 12. So if pin 12 stops working, then pin 13 will either be locked in the on or the off state. Whatever happens, I don't know. I haven't damaged that many I/Os yet. And before I crank up the voltage, my hypothesis is that it won't be damaged because there are diodes on every single I/O pin. The diode goes from the I/O pin to the 5 volt supply line, and so any voltage lower than the 5 volt supply, well, the diode is just in reverse bias, which means nothing's happening. But if it's a voltage greater than, say, 10 volts, 12 volts, that's going to get shorted through the diode, which, if there's no current limiting resistor, it might damage the diode if it heats up. But because the combination of the resistor and that internal diode, I think this is going to work. Well, what should we start at? Let's do 9 volts. Oops, I'm on my current setting. Cancel. 9 volts. Here we go, 9 volts. The LED turned on. No smoke yet. It stayed on, but that's because it's floating. It doesn't have a pull down resistor. It seems to be working fine. Here, watch this. If I touch it with my hand and touch the ground, whoops, it turns off right away. It's just floating. Oh, that's pretty cool. What I actually want to do is measure the amperage, the microamperage of the injection current, and see how close we are to 1 milliamp. 75-ish. Yeah, 75 microamps. Well, 1,000 microamps would be 1 milliamp. So we're doing pretty good. Let's go up to 12 volts. Boom. Ooh, 140. Should still be safe. We're under 1,000. Can we make it up to 24? I don't know. Let's go to 16. $224. Oh yeah, we got plenty of room. Go straight to 24 volts. $24 volts. 24 volts on that Arduino. 393 microamps of injection current into the I/O. Here, that pin is, I should have put a pull down resistor. Doesn't matter so much. That I/O is still responding. Amazing. Well, at this point, 30 isn't much higher than 24, but since that's how high this supply goes, let's do it. 514 microamps, so about halfway there. And that is somewhat what I expected because, well, 47 volts through a 47 ohm or 47 kilo ohm resistor would be a maximum of 1 milliamp. So I would expect that 30 volts would be, well, not quite half, a little more than half, but maybe it's because it's going from 30 volts to 5 instead of 30 volts to 0. But this is really interesting because I have to be careful where I touch this black probe. If I were to touch it to any other point on the circuit, it would instantly fry it. But because I'm going through the 47 ohm resistor, I actually am having an Arduino read a 30 volt signal. Like I literally could have a 12 volt signal from a car or a 24 volt signal from an industrial control go in through that 47 ohm resistor straight into the code. Okay, now it's going to, for data transmission, it's going to be very slow because 47,000 ohms is a lot of impedance, and that makes for a slowly changing voltage. So if you're trying to clock this at thousands, hundreds of thousands of times per second, then you might not, that might not work. But for slow, relatively slow buttons and switches or other digital I/O signals, you know, you probably still should not do this if you have a better way of using an opto isolator or a transistor in between. But just so that you know, this does in fact work.